All right, let's get this going. So I'm Olshansky. I'm Daniel. I usually go by Olshansky, CTO at Grove, head of protocol at Pocket Network. And I'm going to be talking about Gate. So gateway, abstraction, technical elements. And no, this isn't Watergate. It's not another scandal. Don't worry about it. This is going to be fun. And in case anybody thinks they may have seen me before, it's because you have. I was here at DN for last year, and I was actually at Ethereum Denver the 2 years prior. But enough about the past. Let's jump into what we're going to be talking about today. So I'm going to be talking about abstractions. I'm going to be talking about gateways. I'm going to be talking about trust delegation. I'm going to be talking about the thing that probably nerd-sniped you into coming here today, which is ring signatures. And then we'll talk about something called GNAP. This is, you can go to OAuth.xyz if you want a head start. But in case anybody's thinking, oh man, abstractions, gateways, all this stuff, don't worry, I'm not creating a new standard. I'm just going to give a name to an existing standard and give us a way to classify something that already exists. So, but if you do get scared, we got Jackie Chan out here to help us, and he'll keep us going. So this is what I call the abstraction triad. On one side, we have account abstraction. Very, very simple. You go from externally owned accounts to smart contract wallets. You get gas sponsorship. You have social recovery. But the important thing is that this happens on-chain. On the other side of this, we have chain abstraction, right? Intents, cross-chain liquidity, unification of a user experience. But the important thing that I really want to call out is that this happens cross-chain. In the middle, this is the thing that really makes a product work. We all use gateways, we all need an endpoint, we all care about SLAs, we all care about quality of service, but we don't have a name for this yet. And the important thing that I want to call out is that this happens off-chain, right? So in order for us to go from Web 2 to Web 3, in order to go from account abstraction to chain abstraction, what we need is gateway abstraction. And I want to be very, very clear that I'm not presenting anything new today. So this blog post from Moxie, it was an instant classic over 3 years ago. Who here read the blog post by Moxie, by the way? Okay, we got one reader, but basically Moxie's the founder of Signal. And what he said when he first went into Web3 is that nothing's really decentralized. Everyone's either using Infura or Alchemy as their RPC providers, and this whole big vision never came to reality. 3 years later, in some ways, nothing has changed. In some ways, everything has changed. We still use RPC providers, but instead of 2, we have like 100. So those are abstractions. Let's jump into gateways. And no, gateways are not a conspiracy. So I'm just making sure Keanu Reeves knows that. But why do we need gateways at all? We need gateways in order to create an RPC call. We need gateways in order to enable a client to make a call, to call a remote procedure on a server. And you can think of RPC as the medium, and you can think of APIs as the languages that we speak on top of that medium. And if you have ever been to any one of my other talks, you know that the one thing I mention in every talk is the RPC trilemma. I'm not going to give up until this catches on, because the only real thing you need from an RPC is for it to be reliable, performant, and cost-effective. Everything else, decentralized, permissionless, authentication, price, like it doesn't really matter. All of that falls somewhere within that triangle, but that's all you need from an RPC. And then when I went down the rabbit hole of gateways and tried to find kind of a real classification of how we can put one into the other, like load balancers, reverse proxies, API gateways, all I really found was like this really nice one-pager that's really complex. But I found some cool stats. So who here knows Cloudflare? Okay, so yeah, we're all familiar with Cloudflare. And I found out that they're handling 50 million HTTP requests per second. This is a really cool metric, just because it shows not just the scale of gateways, but the opportunity that we have in Web3 and the bridging of Web2 to Web3 when it comes to managing and deploying gateways. But because there was no classification, I went to my good friends ChatGPT Deep Research, Perplexity Deep Research, Claude Deep Research, and this is the gate framework that we came up with together. And basically what I realized is that we overuse the term gateway, but any type of gateway can probably fall into one of these layers. You're either an entry point, you're a guard, a courier, or a translator. And all the products or services or frameworks you're using probably fall into these layers, either in Web 2 or in Web 3. So for example, in Web 2, we have things like Envoy proxy or Kong on the entry point layer. In Web 3, we have something like Grove or Infura. In Web 2, we have something like Tor Signal on the courier level. In Web 3, we have something like Nostr or Pocket. So we have the gate framework, and now you're thinking, all right, so you're talking about abstractions, you're talking about gateways. Why does any of this matter? Well, it matters because it's still an unsolved problem. On one side, consensus says we need a paradigm shift to integrate gateways, gateway modules into every node. On the other side, we have something like the Arweave ecosystem that has a full ecosystem built around gateway specifically. Nostr, if you go to their website to run a relayer, they basically say that you can run your own relay, but it's really, really hard, so just trust someone else to run it for you. And since my talk was actually condensed a little bit and I have less time, I wanted to keep this interactive, but I wanted to guess, like, what do you actually think about when you select an RPC provider? And you know, there's chain availability, there's features, there's correctness, but what I would guess is that very few people here care about the privacy and anonymity of the users actually making the RPC request. So I've been cooking, I've been speaking, now it's time to put everything together. All right, you guys ready? Okay, here's everything I've been talking about on one page, and I'm about to present a solution to one part of this problem. So on one side, we have a user who writes a check, signs the check, wants to move the balance from one place to another, and is willing to pay a fee. On the other side, this is going to settle on one chain or multiple chains through chain abstraction. But in the middle, you got to take that check, you got to put it in an envelope, you got to put it in a mailbox, someone needs to sign it, someone needs to pay for a stamp, someone needs to deliver it, right? And the key thing that I want to highlight is who pays for that stamp and who signs that envelope. Or in more technical terms, who pays for the API request and then who signs the API request. Not the check itself, not the transaction, but the wrapper, right? And the reality is we use OAuth 2 mechanisms to solve this. JWTs, static API keys, it's all pretty traditional. And I would also say that somewhere along the stack, you're probably hard coding a host name or an IP address, either in your code or in your address book or in your seed. This is what really happens. So the solution to this is to leverage our beautiful, permissionless, distributed ledger. I'm bringing back the narrative from 2017, DLT technology, because we have a ledger with public keys. So what the user can do is take their private key, delegate trust to any other public key that they want. So when it comes to signing that envelope and paying for that envelope, any institution they have delegated trust to can do it. The reason this is important is you don't need threshold cryptography, you don't need Shamir secret sharing, you don't need anything interactive. It's very, very simple on this ledger, and you can stop trusting the institution anytime you want. What I call this is the universal API signature, because any service can be paid for through the circle of trust. And now this is the cool and fun part, is that we use ring signatures to make this happen. You take the public keys of the user, you take the public keys of all the institutions you've delegated trust to, and only one party needs to sign it. Who signed it? You don't know. It's anonymized. Who signed it doesn't really matter, because anyone can pay for it. That's the whole idea. But then at the end, we have a universal API key, which guarantees that it was someone in that circle. And so if we put everything together here, you can see that the user has their private key. You can see that the institution has their private key. But the one paying to sign the envelope and the one paying for the stamp is a universal API key that we have made possible through the DLT technology, through the delegation of trust, and then through the signing of ring signatures. But just one more point before I go, because there's another reason this is really, really, really exciting. There's this thing called GANAP. Think of it as OAuth 3 that's not backwards compatible with OAuth 2. This has nothing to do with crypto. This is part of the IETF. And in 2019, they started talking about delegation, signatures, and trust. And basically what I want to say is the problem they're trying to solve with the new RFC that was published by the IETF is that they don't have a way to non-interactively delegate trust from one party to another. So I've already contacted them, and I think this is actually our opportunity not to bridge Web 2 to Web 3, but to bridge Web 3 to Web 2 by using distributed ledger technology and this ring signature solution that I presented. So there's a lot of nuances, there's a lot of detail. I can go into much more depth on all of this. So I'm getting cut off. I'm Olshansky. Thank you very much for listening, and I'll find you guys around.